All right, guys, good evening. So in this particular tutorial, we'll be having a lot of questions to solve, ranging from polynomials to logarithm to binomial expression, and then we could also solve some questions on mathematical induction. We could also solve some questions around set notation. So we'll see how the time permits us to solve all of these questions. So I prefer we start our class with a question on polynomial. All right, let me try and write the question out. You can make an attempt if you can. We're told that if x plus 5 and 2x minus 1 are factors of the polynomial we have here. So this is the polynomial. The polynomial is written as ax cubed. This is polynomial to the degree of 3. It's 1x squared plus bx minus 10. So the question told us to find, we have to find the value of a, the value of b, and we have to find the remaining factors. So this is our very first task for the night. And let's see how we are able to solve this question. All right, can you confirm if you can hear me perfectly? Please, can you confirm your audience? All right, okay, you can hear me. All right, that's great. So please pay real attention. This is a question that came with a total of 6 marks. So the question we are solving right now, if you are able to solve this question, Mathematics 001 last year, you will be getting a total of 6 marks out of a possible 15 in just solving this question. All right, so let's see how we go about this. Let's try and study the question before making an attempt. We're told that x plus 5, 2x minus 1, they are factors of this particular polynomial. So they are factors of this polynomial. We're then told to find the value of a, the value of b, and the remaining factors. Now, put into consideration a particular law under the factor theorem. I'm sure you should understand the factor theorem and the remainder theorem. Under the factor theorem stated that if x minus c is a factor. This is what the factor theorem said. Now, if x minus c is a factor of a polynomial, is a factor of polynomial px, then p into bracket c is equals to 0. This is the factor theorem, which will be very, very important in solving this question. So the meaning of this is that if you say that x plus 5 is a factor of this particular polynomial, that means, of course, you know that x here will be equals to minus 5. You know, you can see now when x minus c was a factor, you went on to say p of now x being c, because when you cross this over to 0, you know, this would be x equals to c. P of c should be equals to 0. That means in this case, if x minus 5 is a factor, of course, we know that x equals to 5 here. That means we are saying that, sorry, x plus 5 rather. So that means x equals to minus 5. So we are saying that p of minus 5 must be equals to 0, according to the factor theorem. If you can understand how this goes, you'll see that this factor theorem is key to solving this question. So that means, on the other hand also, if 2x minus 1 is a factor, of course, we know that x here will be equals to 1 over 2. Somebody asked me how x is equals minus 1, or how x is equals to 1 over 2. I'm sure you have solved quadratic expression, and I'm sure if you had these two factors, I'm sure you understand how to come from here and say x equals to minus 5, or x will be equals to 1 over 2. That's crossing. That will be 2x minus 1 equals to 0, x equals to 1 over 2. I'm sure you understand all these theories. So now, but the case I'm trying to make here is, if you say 2x minus 1 is a factor, according to the factor theorem, that means we are saying when we fix in our x into our polynomial, when we have p of 1 over 2, we must get a value of 0. That's according to factor theorem. So that's key to how we're going to solve this question. So we're told that x plus 5 and 2x minus 1, they are both factors of this particular polynomial. We then want to find a, b, and the remaining factors. So now that you have known this factor theorem, let's now see how we apply this in solving our questions. So the very first thing we have to do is to make use of this factor theorem in finding our a, b, and c. Let's see how we do that. So go on to apply the factor theorem to this particular question, and let's see how we're able to resolve this question. All right, now look at what we have here. Since we said x plus 5 is a factor and 2x minus 1 is a factor, that means, of course, x equals to minus 5, and that means p of minus 5 should be equals to 0. And what this means is that fixing minus 5 into this particular equation, we should get 0. That means we have, how do we get p of minus 5? This would be a, wherever you see x now, you are fixing minus 5. Don't forget, this is px. Originally, having minus 5 in there means wherever you saw x in this polynomial, this p of x represents the polynomial. So wherever you saw x, you're going to be fixing minus 5. So minus 5 raised to power 3 plus 31 minus 5 raised to power 2 plus b minus 5 minus 10. I'm sure you can observe what's going on here. So if you go on to do minus 5 raised to power 3, of course, you get minus 125a. This will be minus 125a. Minus 5 raised to power 2 is 25. That's 25 times 31. That's 775. Plus, or rather minus, because we have minus in the bracket, that will be minus 5b minus 10. Now, don't forget the theory said, when we fixed in our minus 5 here, the theorem said we must get 0. That means this equals to 0. That's the theory based on the factor theorem. All right, if you go on to dissolve this, you can see 775 here and 10 here. 775 minus 10, that'll be what? That'll be 765. If you go on to do dividing both sides, okay, let's go on to just write this first. Minus 125a minus 5b plus 765 equals to 0. Now, you can divide both sides everywhere by 5, obviously. And then you'll be getting, of course, minus 125 divided by 5 will be what? It will be 25. Minus 25. Let's divide through by minus 5 rather. So dividing through by minus 5, we have this one as 25a. Of course, minus 5 will go, this will be plus b. Then this will be plus, minus, because we are dividing through by minus 5, minus 153 equals to 0. So we can make this like an equation like, so we have it like this, so that we just cross this over here. All right. So this is our very first equation. Here is our very first equation. Please note this somewhere in your notes. Make sure this is noted. So this is where we fixed in x as minus 5. Don't forget the theory we're using here is the factor theorem that said when you fix in the root, a particular root of the polynomial, which in this case x equals to minus 5 is one of it. When you fix it inside here, you must get 0. That's the theory we're using. So let's assume we're done with this. Let's go on. This is just for one side. Let's go on to do for 2x minus 1. And let's see where that takes us also. So note this somewhere. Note this somewhere in your notes. So I'll be rubbing this off and going on to solve for when 2x minus 1 was the case. All right, now in this case where we had 2x minus 1, what we had was x being equals to 1 over 2, not minus 1 over 2. So in the case where we're dealing with 2x minus 1, so our x there was equals to 1 over 2. So we go on to say p of 1 over 2 should be equals to 0. And what does this mean? That means if I go on to solve, putting my 1 over 2 here, that'll be 1 over 2 cube plus 31 1 over 2 square plus b 1 over 2 minus 10. I'm expected to get 0 according to the factor theorem. That's just the whole point. The whole point is using your factor theorem right here. Looking at what we have here, if I go on to solve this, of course, 1 over 3 raised to power 3 will be 1 over 8. So this obviously will turn to a over 8. You can understand with me, 1 over 3 raised to power 3 is 1 over 8. That's 1 over 8 times a. Then plus 1 over 2 squared, that will be 1 over 4. This will be 31 over 4. Then we have b over 2. Then we have minus 10 equals to 0. So if you go on to solve this, if you multiply, of course, if you want to solve this much better, you just have to multiply through with 8. So if you multiply through with 8, which was in highest denominator here, of course, this will turn to a. This will turn to a. Multiplying this one by 8, that will be 2 times 31, because 4 will go in 8, 2 times 31, that will be 62. And then multiplying this one by 8, that will be 4 times b, that will be plus 4b. Then multiplying this one by 8, that will be minus 80 equals to 0. That's how we are able to remove the denominator. All right, let's see what we have next. In this case now, 62 minus 80 will give us what? 18. Minus 18. So that will be a plus 4b minus 18 equals to 0. So as we did in the other case, we can shift this over here. So we'll be having this. So now we have been able to get the system of linear equation. We have two equations now. I'm very sure everyone here can solve these two equations. So this was the second equation, just in case you have forgotten, but I'm sure you wrote it down. We have 25a plus b equals to 153. This was the initial one we got. So can we all go on now to use our understanding of simultaneous equation? Of course, these are two equations occurring simultaneously. So we can solve this using the understanding of simultaneous equation. How do we solve this? And what's going to be our result? Can we go on to try and solve this simultaneously? So while you're at it, I'll keep solving mine here, but you can go on solving yours also. So we have two equations and we have several methods to solve equations like this. We can use the substitution method or the elimination method. In this case, I'm not sure you want to even try and use the graphical method. Of course, you can use the matrix method also. So let's look at what we do here. I will decide to use the substitution method. And from what I have here, I'll be taking my b to be equals to 153 minus 25a. Of course, why not? You can do whatever you want to do. It's up to you. So this is what I'll prefer to do. So, and I'll be fixing this b being equals to 153 minus 25a into this very first equation. Maybe I call it equation 1 or something. So what I'll be having there will be a plus 4. Now b is that. That will be 153 minus 25a equals to 18. So opening this up, I will have a plus 612 minus 100a will be equals to 18. If you do this, you will get a minus 100, you will get minus 99a equals to minus 594. Because 18 minus 612 will give you minus 594. Dividing both sides by minus 99, you will get a equals to 6. And of course, if I've gotten my a to be 6, I can easily get my b, which was equals to 153 minus 25a. So my b will be equals to 153 minus 25 into 6. And then I'll be having 153 minus 150. And that will give me my value of 3. All right. So I've been able to get the first part of this equation. My a is equals to 6. And my b is equals to 3. How cool is that? Don't forget, I told you this was 6 marks out of 15. So if you did this in your exam, this is almost half of the mark. How many of you got your answer as a equals to 6 and b equals to 3? All right, let's ride on, because that's not the end of the question. We are told to find the remaining factors. How do we find the remaining factors here? All right, quite simple enough. So we're given this, we already know our polynomial now. Now that we've gotten a and b, our polynomial is very much obvious now, because before our polynomial had a and b present. But now we look at the polynomial right here. This was a polynomial. You see, it had A, it had B. But now that we have successfully found our A and B, we can go on to rewrite our polynomial now in such a way that we don't have to write A and B anymore. So what we can have now for our polynomial, P of x, of course, instead of A now, we'll be having 6, because A is 6. That will be 6x cubed plus 31x squared. That was defined there already. Then plus, now we have 6x. Sorry, B was 3. That's 3x. Then minus 10. So this is my new polynomial now, without having to use 6, or without having to use A and B. All right. We can go through two different methods in solving this. I don't know which will be your preference, but I'll tell you which I will be using, and then you can use your own preference. All right, so now that we have this, you can make use of course, you know two factors already. So the two factors known, the two known factors, these were the known factors. We had x plus 5 and 2x minus 1. Those were the known factors. So if you multiply them together, if you multiply these two together, you'll be getting a value of 2x squared. You can go on to multiply this on your own. Multiplying these two factors together, you get 2x squared plus 9x minus 5. Now looking at this, of course, you understand that if you are told that something is a factor of something, of course, these two are factors of this. That means if you divide this particular one, if this, of course, these are two factors and the multiplication was this. If you divide this particular polynomial with this, what you get will be the remaining factors. Let me say that one more time. This is a polynomial. These are two of the factors of the polynomial. The meaning of polynomial of factors means more like if you had 15. If I say what are the give me factors of 15, I tell you 3 is a factor, I tell you 5 is a factor. So if you were able to tell me that 3 was one of the factors, if you were able to tell me that 3 is one of the factors of 15, if I want to get the other factor, all I will just say is 15 divided by 3. I will get the other factor. So in this case also, if you told me that this is a polynomial and this is one of the factors, that means this divided by this will give me the other factors. It's quite simple. So you can go through that method using the division method. That means going on to say this divided by this to give you your other factors. So another way of solving that is coefficient comparison. Coefficient comparison. So what I can say here is I can say, of course, I know what factors mean. As I said, 3 times 5 is a factor. It's like writing 3 and 5 equals to 15. So I'm not wrong if I wrote that 2x squared plus 9x minus 5 multiplied by a particular unknown factor. If I tell you that these two multiplication must give me my final answer, I'm not wrong, because if this is a factor, this is a dummy factor. You can see it's a dummy. So don't get too wrong. Don't get too confused with what we have here. This is a dummy. It's a dummy and it can take any shape. C can be a negative value, can be a positive value. D can be a negative value, can be a positive value. But you can see that it's taking the shape of all the other factors. Something x plus 5. You can see it can be something. It could be 1, it could be 2, it could be minus, it could be anything. Here we had 2 as C. Here we had 1 as C. Here we had 5 as D, we had minus 1 as D. So this is just a dummy. I'm just saying this particular factor here multiplied by another factor will obviously should give me my final result. So this is coefficient comparison. Let me tell you how it works. So looking at what we have here, so So I'll go on to expand this and get expand these two things. I will expand them fully. I may not be doing that right here, but I have the answer right here. Let me write the result of the expansion. That means the multiplication of these two things must give me this my answer, my polynomial, because this is a known factor multiplied by an unknown factor. The two of them is what should give you your answer here. So let's try and solve expanding this. I won't be expanding it. I'll just be writing the results. You can go on your own to expand. So if you expand these two things on your own, this is what you're going to get. You're going to get 2c x cubed plus 2d plus 9c. This is after we have categorized and classified them based on the power of the unknown. So in this case, all that had the power of 3 was classified in one place. This had all the power that had 2. Then we have plus 9d minus 5c. Of course, just the power of the unknown being 1 here, minus 5d. You can go on to expand this and you will get this answer when you are done classifying them together. So just for the sake of not wasting time, we don't need to go on to be expanding these two things together. So expanding all this will give you this. Now, how do we use coefficient comparison? Looking at what we have here, I can see clearly that you can see this is for the x cube, this is for the x cube. So if this was for the x cube, that means from here, I can see that 2c is equals to 6 here. So I can write 2c equals to 6. Of course, here, my c must be equals to what? 3. So that means I already know in this case now, it will be 3x. I've gotten a part of my factor. Don't forget, it's the remaining factor we're looking for. So I've gotten my power of my c, the coefficient of what I need here. For the d part, I can look at this part here easily. This is minus 5d. This is minus 10. So I can easily say minus 5d is equals to minus 10. Of course, in this case, my d will be equals to 2. So obviously my d is 2, so plus 2. So the other factor I'm looking for is actually 3x plus 2. That's how you solve these questions, nice and neat. And if you have been able to do this in an exam or in this particular exam, that's 6 good solid marks for you. So that's how to get your A in this particular examination. You have to be up and doing in every topic, because this is last year's past question carrying a total of 6 marks. The very first question was the question I solved in one of our previous classes on mathematical induction, when you were told to prove that a particular expression was an integer multiple of 4. And then the second question is the one we are solving. The first one was 6 marks. This other one is 6 marks. And the last question there, let's try and solve the last question next so that we can be very sure of getting our 15 marks in this particular question. So let's try and solve. It's a logarithm question, very simple, and it carried a total of 3 marks. Let me see how you fare with this particular question. I'm sure you guys all followed this particular one we just solved. I'm sure you can really relate to it. I don't believe you had any issue. Can you give me a feedback quickly while I clean this up? What's your feedback? Was it very understandable? Are you having issues? Were you able to comprehend what we're doing? Hopefully you didn't join us late. So these are likely questions for the exam coming up. You have to be ready for every topic so that you don't miss any mark. Yes, you can divide. Someone is asking, can you? So it's easy. Oh, that nice. Okay, someone is talking about the board. We have to manage the board the way it is because we're making the best use of what we have. Yeah, dividing will be easy, obviously, but I know it's based on whatever you understand and can always relate to. So, but I find it quite easy to do any one of them. To look at the next question that carried a total of 3 marks, which completed our 15 marks for question number 1 of the question type. Question type I'm using here is question type MSC 031. All right. They said with the aid of logarithm, solve the equation. This is the equation to solve with the aid of logarithm. You should not use more than 10 seconds to solve this question. And it's just 3 marks. So you get 3 marks for solving this extremely simple question. Yeah, dividing is easy, of course. Dividing is easy. I think both is easy, actually. So how do you solve this? Very simple. I don't expect anybody not to know this. Of course, the very first thing you do is using the law of indices that says when you have the same power. Because when you have a raised to power x multiplied by b raised to power x, by the law of indices, you are permitted to say a times b raised to power x as per the law of indices. Now, looking at this, we can easily convert what we have here to, rather than having 4 raised to power x, 3 raised to power x, we can have it as 4 times 3 raised to power x equals to 12. So this will be 12 raised to power x equals to 12. You know, I told you you should use just 10 seconds. You will say I'm already using up to 60 seconds, Abby. It's because I'm explaining to you. So bear with me. So what do you feel we do next? Don't forget the question said, solve with the aid of logarithm. So what you need to do next after using the law of indices is go on to take the log of both sides, which I believe you can all do easily. So taking the log of both sides, we have log 12 power of x equals to log 12. And I'm very sure you all agree with me. Everybody on this feed, nobody is going to disagree that I can write this particular one, this one we have here. I'm sure nobody disagrees rather, that this is the same thing as x log 12. Of course, that's a particular law in logarithm that you can have it like this. So if you have it like this, this will be equals to log 12. And from here, are you seeing the answer already? From here, my x will be equals to log 12 over log 12, which is equals to what? 1. And that's 3 marks. Can you imagine that? I don't think I will be that buoyant to give students 3 marks for these very simple questions. I don't think so. I hope you didn't hear me say that anyway. Okay. All right. This is possibly one of the simplest questions that JUPEB ever asked any student. This is quite very simple. You just need to apply like two laws, one of logarithm and the other of indices, and that's all. That's the question. 3 marks. So you can see that if you understand mathematical induction perfectly well, and you understood polynomial well, and you understood this well, Math 001, you can get full 15 marks. Let me try and show you the question paper so you, just for a while, so you can understand what I'm saying. This is it right here. 15 marks. You are done. You are done. That's the whole question. So you don't have to sweat over getting A in this particular exam. All you need to do is just ensure every topic is solid in your mind. You understand how to do each and every one of the basics of these topics. All right, so I want us to go into, I have more questions, and we're running out of time. I want to see how, should we do a question on sets? I still have 2 questions on polynomial to solve this night. I don't know if I'm going to solve them though. Maybe we'll suspend some to tomorrow. And I also have a question on set. I think that question was carrying a total of how many marks? 3 marks, yes. And it's also the last question in one of the questions we have solved. We have solved 2 of the questions. The first one was on partial fraction. I think we have solved something like that already in one of these classes. The other one was the one on trigonometry. I think we have solved that also. Yes, we have. And then the last question there was a set question. So this one will not take us. This is probably the second simplest question. I don't know. It and this one, I don't know which one will be the simplest, but let's see. So we have, after this, then we can go on to probably solve the polynomial. I think we need to do more on polynomial this weekend so that you guys can get better in that also. And possibly if we have time, we can solve a past question. I have 2 questions on mathematical induction. But wherever we can stop this night, we'll stop, and then we'll pick from there tomorrow. All right, this question said, given that the universal set was this was the universal set. We had it in notation form. Please pay attention to every detail. Very, very important. Oh, we're not done here. Pay attention to all the details given. So you are told that x is an element of integers. However they draw this, just a z, and then it's a Greek way. You understand that? I know. They said x was integers, and we're told that a had this, and x is a prime number, and we're told that b had this, and x is odd. We're then told to find a delta b. Can you relate to this question? Is it very relatable? Hope you have an understanding of what to do here. Or do I need to give any proper explanation on this? This looks like a 1-minute answer. Like you should just use 1 minute and you're done with this question. I'm sure some of you are wondering how people did not have too many A's last year, because these questions are too simple. Actually, the whole questions were actually simple. But you know, preparation is always the key to all these things, and that's why we're here, so that you can be very solid in what we're doing. So look at what we have here. Let's try and bring out the universal set. You have to bring out all these things. You see, the major test here, the major test in this particular question is the ability to produce all the elements of this set. So we are told that the universal set was this. How do you interpret this? Don't forget, you can see number 1, they said, of course, x is greater than or equals to 1. That means 1 is less than or equals to x. That means x is greater than or equals to 1. But x is less than 10. X is not equals to 10. Pay attention to that. And they told you that x is an integer. It belongs to the set of integers. So let's try and bring out values that are here. We have 1, we have 2, we have 3, we have on and on and on. We end at 9. Somebody says, why don't I include 10? Because they didn't tell me it was equals to 10. All right, let's see our set A. Our set A, we're told that the values there contain x and x is a prime number. Of course, don't forget set A is a subset of the universal set. So your values will be taken from the universal set. You are not just picking all the prime numbers that exist in this world. You are taking the prime numbers that are in the universal set. Okay. So what do we do here? We have prime numbers. What are prime numbers? Is 1 a prime number? Of course not. Prime numbers are numbers that has two factors, two divisors rather, and of course factors probably. We call it factors too. And that's 1 and itself. So 1 is not a prime number. So we have 2, we have 3, we have 5, we have 7, and that's all for prime numbers. Is that correct? Okay. For our set B, which belongs to the same universal set, we are told that x is odd. So what are the odd numbers we have here? Of course, 1 is an odd number, 3 is odd, 5 is odd, 7 is odd, 9 is odd. So the next thing is, what does this imply? What does this particular thing imply? Well, this implies values that are in A but not in B, union B but not in A. Did you get that? Now, if you can understand what this means, this obviously means which values do you have in A but are not in B? Let's try and solve for the first one. A but not in B. In A but not in B. Let's see those values that are in A but not in B. We can see 2 is in A but not in B. What else do we see there? Nothing else. All right. The next one, we're done with A not in B because that's the only thing we can see there. Only 2 is in A but it's not in B. The rest, 3, 5, and 7, they are in B also. So it's only 2 that is in A but it's not in B. All right. Now we want to go on for our B but not in A. What values are in B but not in A? B not in A. We have 1 is in B but it's not in A. 9 is in B but not in A. So now, what's going to be my answer? Let me wait for you guys to tell me. What's going to be my final answer now? What's going to be my A delta B? A delta B. Geniuses in the house, what's my A delta B? A delta B. I'm waiting for geniuses in the house. All right, I think I can see you guys. So my A delta B will be equals to the union of A not in B and B not in A. Of course, the union is you bring all of them together. That will be 1, 2, and 9. That's 3 marks. That's 3 marks free of charge. All right, let's go to another polynomial. We're given a particular polynomial. This is actually quite a question I want you to pay attention to because we have questions like this, very examinable. You are given f of x. You can write it down if you want to. If you want to have this, you can write it down very quickly before I'm done. you're given 6x cubed minus 13x squared. 6x cubed minus 13x squared minus 21x plus 18. 6x cubed minus 13x squared minus 21x plus 18 equals, f of x equals to that. You're then told to find f of 3. That means f into bracket 3. And then you are then told to find to express f of x as a product of 3 linear factors. That's the real deal. That's the real deal here. I want you guys to pay real attention to this question. It's actually a type of this is actually in last year's past question also. That's question type MSB 021. So look at the function you're given. You're given that f of x equals to 6x cubed minus 13x squared minus 21x plus 18. So the very first question said you should evaluate f of 3. And then question number 2 said, using detailed reasoning, you have to express f of x as a product of 3 linear factors. This is really key. I want you to pay real attention. If you know what to do, then you can go on solving. Is anybody here that has not liked this feed? You're listening to me, you have not liked this feed. I will send a bug to your phone right now. All right. Okay. So let's see. What do we do here? The very first question is answerable by anybody. Even if you're in GS1, I think you can actually answer this question. And when you're told to find f of 3, what are you trying to find there? Oh, Tunji is just coming. Daniel is just coming to this class. Huh? All right. All the best, Daniel. F of 3, of course, that means your x here. This means your x is equals to 3. So this means we are having f of 3 as 6 3 cubed minus 13 3 squared minus 21 3 plus 18. So what do we do next? Go on to push this into your calculator. You will get, I believe, 162 minus 117 minus 63 plus 18. What did you get eventually? Thank you. I love that person. Who is that? Who is Ebenezer Chukuka? I love that. F of 3 gave you 0. So f of 3 gave you a value of 0. Now, what does this imply? Any smart person, genius in the house, what does f of 3 giving you 0 implies? It implies something. If you got f of 3 to be 0, it implies something. Can anybody tell me? What does it imply? Thank you, that it is a factor. So that means if f of 3 gave me 0, don't forget, I just told you some minutes ago, for those of you that started this class with us, I told you that factor theorem stated that if f, this was what I said for those latecomers, if f of x, if we had f of x or something, if x minus c was a factor, so I used p then, just let me use p there here also, I said P of C. If x minus c is a factor, then P of C should give me 0. So it's more like a reverse engineering case now. If factor theorem stated that if x minus c was a factor, when you put in c into your polynomial, you will get 0. Now, you put in a value of 3 into this polynomial, you got 0. What does that tell you? That means this is c here. This is what c was meaning here. 3 was c. That means x minus 3 is a factor. Is a factor. So we have gotten one factor. This leads me to question number 2 that said express f of x as a product of 3 linear factors. So f of x is a factor. How do we get the other factors? So this is where we will now go on to use our long division. I know many of you have been loving long division. So let's use long division. For those of you that don't know how to solve long division, please pay attention. Very simple. So cram these numbers or put it down somewhere, x minus 3 and this polynomial. So I'll be rubbing the rest up. Don't forget we're trying to express f of x as a product of 3 linear factors. So I'll be trying to find my other factors now that I've gotten one of the factors. I want to get the rest now. Try and pay attention to how this will be gotten, because this mark, let me check the mark that this carried. The one that came out, it carried a total of 4 marks. This carried a total of 4 marks. We will solve the particular question on this in the past question maybe later, and some other questions on this also later. So let's try and use long division. Those of you that are having issues with long division, try and pay attention. So what you do is you create your tree, you fix in your polynomial inside here, nice and neat. And don't forget x minus 3 was a factor. That's what we're using to divide. So whatever the numerator was, the numerator stays inside here. The denominator, what you are using to divide, stays outside. So let's see how this goes easily. Of course, we start, okay, it's x cubed actually. I wrote x squared. Did somebody not see that? Nobody has corrected me. Or are you guys sleeping? You're streaming in your dreams. All right. Let's see how this goes. What do we do first when we're using long division? We start from using our x value. So we say x goes in 6x cubed. X goes in 6x cubed. Well, the answer will be 6x squared. Where do I write that? I'll write that on top here. On top of the x squared. 6x squared. All right. X going, you use the first letter variable to try and divide the very first term here. So x goes in 6x cubed. The answer was 6x squared. Then you then go on to multiply this 6x squared with each of these terms. So x times 6x squared times x, of course, that's 6x cubed. 6x cubed. 6x squared times minus 3. That'll be what? That'll be minus 18x squared. Minus 18x squared. So we'll go on to subtraction here. Of course, this will cancel out because 6x cubed minus 6x cubed, it's 0. So what are we left with here? We're left with minus 13x squared minus 18x squared. So that will be 5x squared that will be having. If you have an issue with that, you can punch that on your calculator. Minus 13 minus 18. All right, so you go on to bring these other values down here. So you bring this here. What do you do next? What you do next is you ask yourself, x goes in 5x squared. Well, x goes in 5x squared 5x times. So if you're left with plus 5x, you put it on top of the other one. Then you go on to multiply each of these terms with 5x. 5x times x, that would be 5x squared. Of course, 5x times minus 3, that will be minus 15x. Minus 21 minus 15, you are left with minus 6x here. You bring the last value here, that's 18. What do you go on to do? You use this again. This will be x going in 6x minus 6x. Of course, the answer will be minus 6. Then you go on to say minus 6 times x, or minus 6x. Minus 6 times minus 3, that will be plus 18. Of course, these are the kind of places we love to arrive at. Minus 6x plus 18, minus 6x plus 18. When you subtract this from each other, you get nothing left. It's plus 6. What's plus 6? Which one is plus 6? All right, so this is how we got the answer. This was a factor we have gotten before. This is our new factor. So that means we can conclude now that our polynomial f of x has these two factors, x minus 3, and then we have 6x squared plus 5x minus 6. 6x squared plus 5x minus 6. Now, don't forget, we're told to express as a product of three linear factors. If you leave it in this particular position, first of all, you are expressing as a product of a linear factor here and a quadratic factor. So even though these are two factors of this particular polynomial, but you have essentially not answered the question yet. This is a linear factor. This is a quadratic factor. You were told to express as three linear factors. So you have to go on to try and solve this particular factor into linear factors. What do we use to do that? Well, we make use of our factorization. What's our factorization here? So if we have 6x squared plus 5x minus 6, of course, we are looking for a product of 36 here, that's 6 times minus 6, a product of minus 36, and a sum of plus 5 using factorization. If you examine the two factors, minus 4 and 9, you will see that minus 4 times 9 gives you minus 36, and minus 4 plus 9 gives you a sum of 5. So obviously, you can see that we are free to write it as 6x squared minus 4x plus 9x minus 6. You go on to solve this, you will have 2x is common here. You will left with 3x minus what? Minus 2 plus what? Plus 3 into 3x minus 2. So from this place now, I'm sure you understand that this is also equals to 2x plus 3, 3x minus 2. So you can see that we have been able to express this particular value as a product of two linear factors. So our final answer now, in response to the question that we were asked, will be the three answers, the three linear factors will be x minus 3, 2x plus 3, 3x minus 2. So if you look at this, you can see how easy this is. And if you're able to do this for the question that was given in last year's exam, that's a total of 4 marks. So this is how people make their grades. I would love you guys to permit us to use about 5 minutes to solve one question. I don't want us to push this to tomorrow. I think I would like us to start tomorrow on a different note. It's a very simple, one of the other simple questions. I would love you to let's just do it so we don't have to start this tomorrow. So the question read, this was supposed to be the last question. Oh, sorry, 2A. This is question 2A. We are to find the range. Again, let me quickly find out. How do you feel about this last question? How was it? Did you understand it? Was it very clear? Expressing polynomials as a product of linear factors, 3 linear factors in this case. Hope you found it interesting. All right. So let's solve this last question before we go for the night. By the way, just so you guys are aware, tomorrow, if you have issue with sequences and series, if you're having issues with that topic, sequences and series, before our major class, don't forget our classes will always hold by 9 p.m. Friday, Saturday, Sunday. That one is constant. But we want to hold a special class for those that are interested in sequences and series. So if you're having issues with sequences, or you have a friend that has issues with sequences and series, tomorrow by 6 p.m., we'll be meeting each other here. And this is not like in short, this is to ensure that going into the next test, you people will not have any issues in any of all these questions. So, and I would love to have you there. We will solve lots of questions on sequences and series, just sequences and series by 6 p.m. Then by 9 p.m., of course, that one is constant. Everyone must be present. 9 p.m. We'll be meeting, same time, same venue, right here. So this is you are given this question: log 10 2x squared plus 3x plus 8. We're told is less than 1. So we're told to find the range of value of x for which this thing is less than 1. So we are told to find the range of value of x for which log 10 this is less than 1. So I want us to solve this very, very briefly. Seeing it's a very simple question, it should not take us much time at all. How do we solve this? Of course, I'm sure you admit that this particular question, 2x, it can be written as this. And this is just a law of logarithm, of course, that says this raised to, if you want, this is equals to this raised to power this. That's a law of logarithm, which I'm sure this is raised to power 1, just to be clear. This is raised to power of 1. All right, so 2x raised to power 2 plus 3x plus 8 less than 10 raised to power 1. So in this case, what you have to do is to go on to, of course, this will also be equals to 2x squared plus 3x plus 8 less than 10. 10 raised to power 1 is 10, obviously. Then we can bring this in. And we have minus 2 less than 0. Can you try and solve this, please? What do you feel you're going to get after solving this? Of course, I will tell you to go on to solve this because of time using. I will ask you to go on to use your formula method to solve this, if you will. And can somebody do that very quickly? Can you solve this question? We don't have to do it, right? I believe everybody can use the formula. In case you are wondering what the formula method we're talking about. Of course, this is x equals to minus b plus or minus square root of b squared minus 4ac over 2a. Your a here is 2, your b is 3, your c is minus 2. Can you try and use that method to solve this? Okay, okay, I love what I'm seeing. Okay, all right, that's nice. So with what you are solving now, your x1, so our final conclusion would be that the range of value will be minus 2, because you will be getting, when you solve that, you'll be getting your x equals to minus 2 and your x equals to 1 over 2. So your range of value will be minus 2 less than x less than 1 over 2. So I just thought to share that so that we can start on a fresher note tomorrow. So this is how you tackle questions A level without making any mistake. So we have more questions in some of these questions that we'll be doing much later. Like we have conic sections, we have questions like that has not been touched in these tutorials. We also have questions on complex number that has not been touched in this tutorial. So hopefully we'll be doing more of that very soon. And we also still have some questions on mathematical induction that we've not solved yet, although I believe by now you should find those questions very simple, because we have dealt with mathematical induction in these tutorials. So the main key is for you to take things step by step. I mean, topic by topic. So you don't want to accumulate a lot of topics close to the exams. It's best you know these topics at this point, so that when you are getting close to the exams, you are knowing the topics that you have learned closer to the exams. So that's the main key to being successful in these exams. And those of you guys that are following and you're flowing, you're doing really great. I wish you all the best. The sky will just be the beginning for you. We have a question on binomial expansion to solve. We'll be solving that tomorrow also, I believe. And as I said again, by 6 p.m. tomorrow, you can, if you have problems with sequence and series, try and turn up for that for the class. We're trying to make it open to everyone so that we just don't, we give everyone the opportunity to learn that topic much deeper. In case you want more understanding of sequence and series, try and be available by 6 p.m. tomorrow. And the normal class holds by 9 p.m. By 9 p.m., we are all going to be right here, same time, same venue, same duration, and same tutor. All right, guys, I hope you enjoyed your time here today, and I do hope to see you guys tomorrow. And I hope you prepare very hard for the test coming up. 80% is the benchmark for everybody, and make sure you work tirelessly and in the day and the night, whatever you have to do to ensure you get this. Put in the time, put in the effort, and ask for grace when you need grace. Do whatever it takes. Do whatever it takes. You must succeed. You must succeed. You must succeed. All right, guys. I think it's been a pleasure being with you guys this night. Uh, yeah, so we'll be ending this tutorial at this point. Take care of yourself, guys.